What I'm going to talk to you about today is quite a bit of a shift from everything that you've been hearing so far. ProPath is a privately owned pathology lab, so this is a completely different perspective on workflow and products. I'm just going to go over a general overview of what we need to run FISH and what that means, including basics and how we apply it. PET, paraffin-embedded tissue, or FFPE, frequently in our lab, I don't know if it's just a regional thing, we refer to it as PET. We often don't refer to it as FFPE. In PET, the primary thing that we deal with as a reference laboratory is the specimen quality. We don't have a lot of control over what we're getting in. We just kind of have to take it as is, which means a lot of the specimens we either don't know what their cold ischemic time is or it's not in the acceptable ranges, but we still have to continue. Cold ischemic time, I don't know if you're familiar with pathology services. That's the time from removal of patient to fixation. That includes proper fixation, sectioning size, how much they tried to cram in a cassette. All these things have a significant influence downstream. Fixation type, primarily for fish, you want to have neutral buffer formalin, which I think is pretty universal now in pathology services. We really don't see any other type of fixation coming through, with the exception of decalcification of bony tissue, which, if it is acid-based, will ruin your nucleic acid sequences. Chelating methods of decalcification are still useful for fish. However, we don't see that very often because of how long it takes. In the basic steps of PET fish, paraffin-embedded fish, you have to obviously cut the slides, section them, deparaffinize. Then you're going to have to go through a series of steps. Pre-treatment, a digestion, usually pepsin or protease. Then you have to apply your probe, hybridize. There's a stringent post-hybridization wash, counterstain, and analysis. Now, all this comes together, blood and bone marrows and tissues. So you either start with this traditional cytogenetic harvest, which, so you culture the cells, harvest them with some sort of mitotic inhibitor, hypo, and then fix, or a direct harvest, which is often useful in extremely quick turnaround times. You're not looking at metaphase spreads, you only want to look at interphase cells. And those are just going to be a cell pellet that you're going to drop on a slide. For a touch prep or smear, you can put it directly into fix. And for both of those specimen types, you're going to age and dehydrate the specimen, probe it with wherever you're getting your fish probe from, multiple vendors. Again, stringent post-hyb wash, counterstain, and analysis. So we have all these different specimen types coming in from multiple different places around the country and around the world with whatever conditions they have in their lab established before they send them to us. So this means that for every specimen type, there's going to be a variation in the digestion times, pre-treatment times, and then also the vendor of probe that we use for fish determines the melt and hybridization temperature and time. So this comes together to form a very convoluted system for every specimen type, for every location it's coming from. In combination with all the multiple different probe vendors, we have a very convoluted system that we have to keep track of for every specimen. In our laboratory, we handle over 3,000 paraffin-embedded tissue fish a year and over 5,000 total fish, including hematological fish. So as you can imagine, this can get out of hand. So we have transitioned into a quicker workflow. That's what I'm talking about today. So I'm going to kind of go over where we started with this extremely complicated system to where we are now. So starting with reagents, processing, and then finally with results, which is the big part. With reagents, our primary paraffin-embedded processing system we used from Abbott, which was a paraffin pre-treatment kit. And with that, we had multiple different reagents that we had to create by dilution, measurement, pH, filtration. And then because of this wide variety of specimen types and probe vendors, we had a huge list of reagents that were optimized for specific probes, for specific tissue types. So we had to keep all these reagents on hand and make sure they were QC'd, filtered, and all the way, always had them on hand because we never knew what we were getting in for that day. Now we have switched to the histology processing kit provided through DAKO, which is also the same one in the HER2 IQFISH. This is a simple solutions of their stock solutions. You simply dilute them out and you're ready to go. We have been able to optimize all of our FISH assays to these reagents. So no longer do we keep this long list of reagents on hand. We keep these few stock solutions and dilute them as we need them, and we don't have to worry about pHing or measuring things out. It's a very simple solution. The processing, again, here's part of this convoluted system. I've been doing PetFISH now for 10 years, and over those 10 years I've been keeping track of performance of different tissue type and also from different locations, particular labs that process them. And using breast as a baseline in time, and this is with the pretreatment kit that you would use with the path fission assay. So if you use that as the baseline in time in each one of these steps, then based on these variations in tissue type or a particular place that you're going to get tissues from, that also plays, because they swear they fix it the same way everyone else does, and for whatever reason theirs always performs differently. You got to take them at their word, I guess. But this system is what we came up with. So every time we got in a tissue, we have to cross-reference it to this table of what it was optimized to perform at. So say a GI tract, it's over 45 minutes longer for any kind of GI sample versus the standard breast sample. And this is an example of what, even with optimizing the process with all these different times and tissue types, sometimes you still don't get an ideal FISH prep. There's background, you have poor resolution of your nuclear membrane, and that's the best we can do. That's at the best that we optimize these tissues to. Now, it doesn't matter the tissue type, breast to GI to lymph node to lung. With the histology processing kit that's included in the HER2 IQFISH and in their histology accessory kit, everything gets the same time, whether it's breast, lung, brain, everything. We can batch things together, throw them in together, same amount of time, and then just worry about which probe's going on which tissue type later. This is an overview of the two different types of pretreatment. This is just for PetFISH, the two types of pretreatment kits that we use before and after, and some comparisons between them. Is my laser pointer working? There we go. The total time here, one little caveat about this total time is that's at the minimum starting at the breast standard, which is why this says minimum here instead of the full range. Again, for GIs, you're going to add 45 minutes minimum onto that. So this is extremely dependent upon tissue type. Whereas over here, again, everything goes in together. There's no variation based on tissue type. So in 1 hour hands-on time, we're ready to probe, and we're ready to move on. And this 1.5 hours hybridization has really improved our overall workflow versus an overnight hybridization. And this, again, is just for HER2. That means you're going in 1 day from starting the process to being able to counterstain to analyze versus an overnight process. When you're looking at other probes besides HER2, which is the FDA protocol, so we have to follow it step by step, when you have other probes involved, you have to, again, look at how you optimize that specific melt temperature and melt time, hybridization temperature, hybridization time, generally overnight. Even though we changed the way we process the specimens to have them ready for probing, we didn't change the melt or hybridization conditions of any of the probes. What that did was allow us to not have to completely revalidate every assay from the beginning. We just showed that the probe continued to perform as expected with current conditions, and we only changed the processing type. Again, the exception there is that we switched to the IQ HER2 FISH PharmDX FDA protocol, so all protocol, we follow that to the T as expected with the FDA kit. So you probe the next day, typically overnight, except with the HER2 IQ. You're going to do a stringent post-hybridization wash. Again, multiple probes, multiple vendors. We optimize every probe that comes in, every probe that we buy. We optimize which reagent type was the best for stringent washing, time and temperature, and if it needed a secondary wash. And as you can imagine, for over 50 probes, this was an extremely exhaustive process. But again, the quality was our primary concern. So this was what we were doing before. Again, there's all those different reagents listed in and how we use them for particular probe vendors, specimen types. Now it's all one stringent wash, which is provided in that kit. We use that not only for PET, but we also use that stringent wash for all of our hematological slides now. It was a rather easy optimization. Same temperature, we just adjusted the time, and everything performed either better or up to the standards that that probe had been performing before. This is where that sounds great. We made it more efficient, we've streamlined our processes, run things in batches. The hands-on time is greatly reduced. We have very few people working in the lab. With all the samples that we handle for fish, over 5,000 a year, that's just fish. We're also a full cytogenetics lab with the same technologists that have to share all those duties. There's only 6 of us. So we need things to be easy, convenient, and as much batching as possible. And by using the same stringent wash, we're able to, when we do go to wash things, we can just have one Copeland jar of reagent in the water bath without copious amounts of different jars for different reagents going at different times. We had a plethora of timers going off literally almost every 15 seconds to get these samples out in the appropriate stringent wash time. This is the key point to me. As a technologist, I'm reading these. I'm looking at these. Quality is my key concern, is sitting down at the scope and actually having to look at them. I know I'm not the business end of this. They appreciate the improved turnaround time. They appreciate the efficiency, more utilization of their FTEs, that sort of thing. I like being able to sit down and look at something pretty, is what I want to do. And just the quality of the preparations has allowed us to decrease our repeat rates just based on quality. Sometimes the quality was so poor that we could not analyze it, from a little over 4% to less than 0.5%. And if you're talking about thousands of specimens a year and having to add a probe again at a repeat, you can imagine how the cost of that was extremely expensive to go from here, and how much money we're saving now with not considering any other efficiencies or batching or reagent costs. Just the decrease in repeats has saved a lot of money. We were just using a few months worth of data to get that repeat rate, and we were only using HER2. So in 8 months, you can see also our volume is continuing to go up as well. So we are appreciating the batching and the short turnaround time. Now, for the turnaround time for the HER2 fish, it says our turnaround time decreased by 1 day. We didn't decrease it to 1 day because, again, that's not the only assay we're performing. And again, we have a limited number of microscopes, technologists, and time. We're not a 24-hour lab. We're a one-shift lab. If it was the only assay we were doing, we would be able to crank them out in the same day. But a lot of other factors go into that, including that the pathologists leave much earlier than we do. So even though we were able to get them out by the end of the day and ready to be reported, there's no one there to sign them out for a pathologist. So there's a lot of other things that go into that besides just an hour-and-a-half hybridization. Optimally, we will have enough technologists and enough microscopes to do this soon. But as of right now, we have just been able to decrease our turnaround time by 1 day, not to 1 day. Using the histology kit in combination with the IQFISH. Again, we've already switched to HER2. Now we're looking at some other probes that we already have from Agilent. They're SureFISH probes. We were able to use them with the IQFISH buffer and get the hour-and-a-half hybridization time. And that sounds great, but the best thing was it didn't decrease the quality or performance of the probe. If anything, it improved the quality and performance of the probe, including any background. So aside from a turnaround time, hybridization time aspect, just the quality of the assay was improved. That means we can complete, do I need to hurry up? We can complete everything in just 1 day, including any stat hematological FISH assays such as PML RARA. She's rushing me here. So, as we're bringing on more probes, we want to consolidate down to one probe vendor. That just makes common sense. We want to consolidate purchasing as much as possible, especially considering I'm in charge of purchasing. And we're trying to get more and more probes on the hour-and-a-half hybridization. I really want to get to this. So this was before. It doesn't look too bad. You have nice nuclear detail. And you think, okay, well, that's not too bad. You have some background. This is where it's really impressive. Moving to the HER2 IQ Farm DX. There's no background. All these images are taken full gated. There's no gating on any of the filters. Full exposure with no cleaning, nothing. This is a full image. This is what we saw through the scope. Here's a side-by-side comparison. These are all same samples. These were done side-by-side. Now this is the processing but using a different probe. So again, we're still using the same probes we were using before, and it improved the performance of every probe, not just changing probes to match the processing. The processing improved the performance of all the vendors' probes. This is that slide that I showed you earlier. This is the best we could optimize it before, and this is using the histology processing kit from DAKO. And these are a few probes. This is a negative TFE3 break-apart probe on XP11. Obviously, this is a male because we're only seeing one X. These are all hour-and-a-half hybridizations using the IQFISH buffer, and their quality is absolutely outstanding. This is an ALK. This is an abnormal ALK. That's why you see fusions and break-aparts of the probe with red and green individual signals. This is a known positive. Also, ROS1, which is becoming more and more relevant in lung cancers, and RET also. This is a break-apart probe as well, and this one is negative. This is a comparison of the hour-and-a-half hybridization to overnight hybridization. This is using the same probe, so just comparing, shortening the hybridization did not decrease the quality of what we were looking at. It stayed the same or got better. And a very important one would be PML RARA, which is useful for getting a 3-hour total turnaround time. I think that is it. This is the total group of us. There's not very many of us, 6 cytogenetic technologists. This is the flow lab and molecular lab as well. So technologist-wise, we're a small lab, but we do have very high throughput on specimens.